Day 12. It is Monday, February 3rd. January is finally over. We're in a new month, warming up a little bit. So our do now today is just including some of the stuff we learned about last week, just a little refresher. I gave you some equations and I wanted you to graph the line for each equation and also identify the slope and the y-intercept. So, another calculator. Yeah, go for it. Absolutely. So let's look at number one. Number one, we have an equation that is y equals 3x minus 2. So before we even graph it, let's identify our y-intercept and our slope. So what would my y-intercept be? Say it again. -2. Good. It's just that last number at the end. -2. And what's our slope? 3. Did you say 3 over 1?
Yeah.
Perfect. So our slope is 3, and we're going to put it over 1 so that we have a rise and a run. Okay. So we've got our y-intercept. We've got our slope. How do I start to graph this line?
You put it, what's it, 2?
So put a point on +2 or -2?
-2.
Perfect. -2. That's my starting point, my y-intercept. And where do I go from here?
3.
Up 3. Good. So my slope, remember that's rise over run. So up 3
1
over 1. So 1, 2, 3 over 1. And here's our second point. Perfect. All right, can we name these coordinates? What's our first coordinate? 0. -2. Good. And our second point? 1. Good. 1, 1. Awesome. And just as a refresher, in a coordinate, the x value comes first and the y value is next. That order will not ever change. Okay, so what is the last thing I need to do? I've got my points. I need to draw my line. So I'm going to get my ruler and line it up with those points. Make sure my line passes through both. And here we go. We'll put some arrows on the ends of that line. Okay, any questions on number 1? Yeah.
I thought it would be 3-1 for the second chord.
For slope,
Yeah.
you said 3, 1.
I thought that when you make your second chord it's for that graph.
Oh, yeah? Oh, you were thinking that this point was going to be 3, 1. So if, let's see, 3, 1 would be over here, a little further away. We would have to have a different slope to get 3, 1. So remember, whenever we start with our y-intercept, that's going to give us kind of our starting point. That's where we're going to count from. So since we started at -2 on the y-axis, starting here, then since our slope is 3 over 1, it tells us that first we're going to rise up 3. So that's going to take us up 1, up 2, up 3. And then we do run 1 since it's 3 over 1. And when we go over 1, we end up right there. Does that make sense better?
Yeah.
Okay, good. That's okay. That's okay. Awesome. Any other questions? Okay. Let's go ahead and look at number 2. Number 2, we've got y equals -2/3 x plus 4. What would my y-intercept be?
2 plus 4.
Ooh, it's going to be 4. Yes. So 2 is part of our slope, or -2. But remember, it's always going to be that number at the very end of the equation, plus something, plus 4 in this case. So our y-intercept is going to be +4. And what is my slope?
-2/3.
Yes, -2/3. The number next to x. So my slope, -2/3. Okay. So where's my starting point?
+4.
+4 on the y-axis. So we're going to start there.
Down 2.
Yes. Since our slope is negative, instead of rising up, we rise down. So I'm going to kind of label this over here. My rise is -2.
Over 3.
Yes, and my run is over 3. So we're going to go down 2, 1, 2, and then over 3. 1, 2, 3. There. Okay. Now let's label our coordinates. What's our first coordinate?
4.
Good, 0, 4. And how about our second coordinate?
3, 2.
Over 3 up 2, that's right. 3, 2. Perfect. And what is left to do? Draw your line. Very good. So I'm just going to take my ruler again and draw my line. There. All right, do we have any questions on number 2? This one's a little different. Everybody feel okay about that one? Okay. All right. Let's look at number 3. Give you a little bit of a tricky one here for number 3. I've got y equals x plus 2. So let's look at our y-intercept first. What is our y-intercept?
2.
2. Good. So 2. And what about our slope?
So 1.
So it won't be x. We don't put x in our
Oh.
slope.
No.
1. So remember, if there is no number next to x, we can assume that there's an invisible number 1 there. The number that's beside x just tells you how many x's there are. So if there's not a number and I'm looking at this x, I'm asking myself, how many x's do I see right here? 1. There's 1 x. So if it helps, you could write the 1 in. You don't have to though. And that would mean my slope is 1
Over 2.
not over 2,
Over 1.
over 1. Good. It's just 1 over 1. Anytime you have a whole number and you want it to become a fraction, you always just write it over 1. Does that make sense? Is anybody confused about how we found the slope? Okay. All right. So where is my first point?
2.
2, +2 on the y-axis. Okay. And where should I go from there?
Up 1 over 3.
Up 1 over how many?
3.
So where'd you get the 3 from?
Oh.
That's okay. So our slope is 1 over 1. So remember, we're just going to be using the numbers from our slope to find rise over run. So if it's 1 over 1, our rise is up 1, and our run is just going to be over 1. We're just going to use the numbers from slope. So let's go up 1 over 1. Right there. And I know this one's a little squished, but we'll make do with it. So what would our first coordinate be? The first one we put on?
0, 2.
Perfect. 0, 2. And how about our second coordinate?
1, 1.
1, 3.
Let's see, it's over 1, up 1, 2, 3. Because we went up 1 from 2.
Oh, right.
So that puts us at 1, 3. Oh, I wonder if that's why you said 3
Yeah, 'cause
instead of
'Cause I can't.
1.
I did put
That
the
makes
number in
sense.
there. Sorry.
No, that's totally okay. So we've got our points. And what's the last step? We're gonna make the line. We're just gonna connect the dots. So let's put our ruler through one point. And in the future, if you're trying to graph a line where the points are really squished together, and if you want it to be more accurate, you can actually take your slope and keep going. I know it's up 1 over 1, so I went up 1 over 1. I could do it again. Up 1 over 1, there's another point. Up 1 over 1, there's another point. Up 1 over 1, there's another point. That way you can make your line look a little more accurate. You don't have to do that, but it helps sometimes. Okay, do we have any questions for number 3? Any questions at all? Okay. All right, let's move on and look at number 4. This one's tricky. We talked about this briefly on Thursday. This is one where we might not be able to look at the equation and it might not click in your brain right away what the y-intercept and the slope would be. What did I tell you last time? Whenever you have an equation that just says y equals a number, what's one good way to think about how this graph is going to look?
They go from left to right.
Everything's going to go left to right, absolutely. It's going to be like a straight horizontal line.
You just put the point at 3.
Yeah, exactly. So what this means, y equals 3, is that no matter what point I put on the graph, my y, or how far up and down the line is, has to be at 3 on the y-axis. So I am just going to put a point at 3. I know that's going to be a point. And I could do, let's see, there was a few ways that we could do this. We talked about making coordinates first to help us out. So if I wanted to start by making coordinates, remember my x value comes first, my y value comes second. And if my equation says y equals 3, what do I already know about these coordinates I want to come up with?
Put the 3 by the y and the 0 by the x.
Yes, so y equals 3, that means for every coordinate I write, y is 3 every time, no matter what. So I can put 3 here and 3 here. We did already find one point, and you're right, Jenny, it was 0, 3, so we could write that in. 0, 3. Now, does it matter what I pick for my next coordinate for x? No, I could pick any number that I can see on my graph. So give me an example of a number I could use for x.
2.
2. Let's do 2. So I would go over 2 on the x-axis and up 3 on the y. Just like that. And no matter what I choose for x, my y is always going to be 3. So it could go all the way across like this. It's going to end up giving you that line that's horizontal going straight across left to right. Y is 3. And then we'll just trace the line. And that's all there is to it. Oh, so let's kind of work backwards on this one. Now that we have a line graph, what's our y-intercept? 3. The y-intercept, basically the definition of that is where is the line touching the y-axis? It's touching at 3. So I'm going to write 3 for my y-intercept. And for the slope, let's think about it. Our slope tells us how far up to go and how far over to go. What would our slope be here? 3, 2. So if I start here, I would go up 3, over 2. Can't be a number on top of our fraction, really. Can there?
3 over 1.
So go up 3. 1, 2, 3, over 1.
0.
Ah, 0. It's 0. We have a 0 slope. And I'm going to show you why that works, how we know that. Our slope is going to be 0 because if I make it, for example, our slope could be 0, 1. It could be 0 over 2. It could be 0 over 3. Any of these fractions are still 0. Okay? If you have 0 on top of a fraction, it's just 0 because it's saying I have 0 divided by one person. Like I'm giving 0 of something to one person. How much does that one person have? 0. If I have 0 and I split it up between 2 people, how much does each person get? Nothing. 0. 0 and I split it up between 3 people. They all get nothing. It's still 0. So we're going up 0 and we're going over left to right forever and ever and ever. It does not matter what number's on the bottom. Our slope is going to be 0. Another way to think about how to reason this, I'm going to pull this up a little so we can see. Our original equation that I gave you is y equals 3. And let's think about what form this equation is. We've been learning about y equals mx plus b. This is our slope-intercept form, where m is the slope and our y-intercept is our b. So how about we plug in our y-intercept and our slope into this equation? So I'm going to write y equals something x plus something. What is my y-intercept for this equation? What did we say it was? 3. So plus 3. And what did we say the slope was for this equation? 0. Okay, so here's the actual equation. Y equals 0x plus 3. But if I have 0 x's, should I write x? If I have 0 x's, does it make sense to include x in this? No, it doesn't. So what happens is if I take something times 0, it disappears. So whenever our slope is 0, we don't have an x in our equation, and we just get our y equals 3. See where that came from now? I don't know. I think it's kind of cool. But, you know. Okay. Do we have any questions about that one? I know that one's a little tricky. All right. So that's our do now today. And today for our lesson, before we get started, I have a question for you guys. I want to know on, I'm going to say like a scale of 1 to 10, how confident are we feeling about being able to graph a line in this form? Okay, I'm seeing an 8. Yeah, hold up some fingers. Hold up some fingers. I won't call out your names. You see, like, you feel like 10 out of 10, like 3 out of 10, 0 out of 10. All right, I see a 10. I see a 10. I see a 7. That's good. That's okay. I see you rough. That's okay. All right. Okay, I see a 7. That's good. How do you feel? Like an 8? Okay. All right. That's good. So we're still kind of doing this exact same thing, but we are going to we're going to be staying in the realm of graphing. That's what we're going to be doing for a little bit in this unit. But I do want to show you one more type of equation that you'll see. So let's go ahead and get out our notes. And before we show this new type of equation, we're going to do a quick kind of review of everything we've been doing. And I'm going to use my paper for notes today. I want to give us like a guide. I'm going to label my paper. Algebra 1. All right, day 12 notes. So, Monday. And the title of kind of the topic we're going to be on today, I'm going to say types of linear equations. And here we go, types of linear equations. So the first type that we've been talking about is slope-intercept form. That's our y equals mx plus b. So let's make a quick note of that just to remind ourselves. This is slope intercept form. Slope intercept form is that y equals mx plus b. And somebody remind me, what letter in this equation or which variable is our slope? M. Good. It's just the letter next to x. This is always our slope. So our rise over run. And which variable gives us our y-intercept?
B.
B. Good. And I include the sign usually because that's going to tell us whether we are starting in the positive y direction or the negative y direction. We've got slope there. And then we've got intercept. B. as a coordinate, if you notice a pattern, you might be able to, I'm sure some of you already have noticed it. Anytime we graph our first coordinate, it's always going to be 0 for x, and our y is whatever number is in for b. So there it is as a coordinate, which is good to know, I think. Okay. Now we have another type of equation that we're going to talk about today. And this one is called a standard form equation. Standard form. It's going to look a little bit different. So whenever we have an equation in standard form, this is the letters that we see. We get we're using capital A, capital B, and capital C. We have A, X, plus B, Y equals C. AX plus BY equals C. Now, when we have an equation written in this form, similar to slope-intercept form, you're never going to have a number to replace y and x. So in this case, you're always going to have that x and that y. You'll have numbers that are plugged in for A, B, and C. And with those numbers, we can also come up with our slope and our y-intercept, because that's all you need to graph a line. Is once you know the y-intercept, you have a starting point. When you know the slope, you know how far up and over to go, or how far down and over to go. So I'm going to make a note under it. I'm going to write slope. Show you how we find those here in a minute. And then y-intercept. So I'm not sure how much experience each of you have with rearranging equations, but these two equations, the y equals mx plus b and the ax plus by equals c, we do have the same variables here. We have x and y. We have x and y. These are just rearranged versions of each other. So I'm going to show you how we can rearrange this equation to give us this same equation here, because that's how we're going to find our slope and our y-intercept. Now, as I'm showing this to you, it might look kind of insane, and I don't want anybody to freak out about it, because after I show you how I rearrange it, I'm going to give you the shortcut so that you won't ever have to rearrange it, ever. I have discovered in the now 2 terms of teaching algebra that most everyone I talk to prefers the shortcut, because it is super fast and it is very easy. It's just knowing the letters. So let me show you. I've got AX plus BY. I'm just rewriting this over to the side and showing you how to rearrange, equals C. And I'm wanting to move these around to make it so I have y by itself equals something x plus something. I want y by itself equals something x plus something. Okay, now this might seem a little tricky to do it with letters, so I'm going to also show you with numbers next, but I'm going to show you with letters first. So does anybody have an idea of what I could do to get rid of my x or to bring my x over to the other side of the equal sign?
You're gonna divide.
We can't divide it.
Take away.
Take it away. Yes, we're just going to subtract. I'm going to do minus ax on both sides. Minus ax. And again, keep in mind, I am going to show you a shortcut after this. You won't ever have to do it this way, but it is good to know in case, you know, you want to double check. So if I subtracted ax from this side, what happens to the ax that was there? It's gone. It canceled. So I'm going to cross it off and let's bring everything down. Now I have b y equals, and in slope intercept, I have mx plus b, or a number x plus a number. Right here, I'm going to have c minus ax. I'm going to actually write the minus ax first so that it is closer to being like the slope intercept form. So here's what that would look like. This is what I mean by that. I'll have negative ax plus c. Is anybody confused about how I was able to put ax first here? And it's so okay if you're totally lost at this point, because I think it will all make sense and come together once we get the final answer.
Can the equation always be an A, or will you have different letters up there sometimes?
It will always, in standard form, always be A, B, and C. Always. But typically, you're not going to see the A, the B, or the C. There will be numbers plugged in for A, B, and C. So just like our slope intercept form, we have y equals mx plus b. We don't ever actually see m or b. We see numbers that are replacing m and b. So it's going to be the same concept. But I think once we have this rearranged, you'll understand why knowing what those letters are is important. And we'll do some practice with it.
So you could always say, like you said, the AX, bring it down to the negative A, and when you bring it over there, that bottom number is always going to be the first that you put next to the C or
Yeah.
number or whatever. Blah,
Yeah,
blah, blah.
exactly. Exactly. Okay, so I'm almost back to slope intercept form. But when I'm in slope intercept form, I don't ever have a number next to y, ever. Y needs to be by itself. But I have b times y equals negative ax plus c. How could I get rid of the b?
You divide it?
Yes, you're going to divide by b. So I'm going to divide by b. And I need to also divide each of my terms on the other side by b. So I'm dividing negative ax by b. I'm dividing c by b. Okay? And here's what happens when we do that. Our b's cancel out, and we're left with y equals negative a over b x plus c over b. So that negative a over b is like one number, it's just a fraction. And that c over b is also a number. It's just whatever c is divided by whatever b is. And look at that. Now we're in y equals mx plus b. It's just instead of an m, we have negative a over b. Instead of little b, we have big C over big B. So here's what we can conclude from this. Here's my M. Here's my B, right? So if negative A over B is in the same place that M, or slope, is, then when I have an equation in standard form, what letters would I use to find slope? Can anybody tell me by looking at this rearranged equation?
Negative A over B.
Yes, negative A over B. Good. So our slope is negative A over B. It's whatever this number is, but the negative version over whatever this number is. And what would our y-intercept be?
C over B.
C over B. Good. Okay. So this is where the shortcut comes in, and I'm going to explain that a little better to you. So if I have an equation written like this, I can skip doing all these rearranging steps. I don't have to rearrange my whole equation. I can just figure out, okay, what's my A, what's my B, what's my C? Whatever A and B are, I'm going to do negative A over B. There's my slope. Whatever C and B are, I'm going to do C over B. There's my y-intercept. Now I can graph the line. Now, this might still be like, what on earth is she talking about? Let's make it make sense. Let's use some numbers, okay? I'm going to tear this page out, put it to the side so that I have it to reference, and I'm going to give you some actual examples. Now, before I do that, does anybody still need to see this? Is anyone still writing? Okay. Tear this out. And I'm going to start page 2. So, number 1. Page 2 of my notes. 12. Day 12 notes continued. And I'm just going to title this page to help me if I ever need to look back in my notes and reference it. We're going to say standard form equations. Or standard form examples. I'm going to give you a bunch of examples. Right under that, I'm going to remind myself what a standard form equation is. I'm just going to rewrite ax plus by equals c. So I don't have to keep looking back and forth at my 2 pages. I'm going to write the slope and the y-intercept one more time. You don't have to do it, but I think it's going to help if you do. Slope is negative a over b. Y-intercept is c over b. Here is an example number 1. Let's say we have an equation such as 3x plus 4y equals 5. 3x plus 4y equals 5. And let's say I want to know the slope and the y-intercept. So the first thing I would do is I would identify what my A, what my B, and what my C are. So in this equation, which number is my A? 3. Good. So I'm just going to write A above 3. Which number is my B?
4.
4. That's B. And what is C? 5. Good. So I know A is 3, B is 4, and C is 5. So now that I know what A, B, and C are, how could I find my slope?
3 over 4. Negative 3 over 4.
Yes, my slope is negative A over B. So I'm going to use negative A over B. If A is 3, that means I need to write negative 3 because we're doing negative A. Positive A is 3, so I'm doing negative 3. And when I put it over B, my B is 4, so it's negative 3 over 4. There's my slope. That's my slope. I'll put in parentheses here. We remember that that's just negative A over B. Okay. Negative 3 over 4. And what would my y-intercept be?
5 over 4.
5 over 4. So normally we don't see a fraction for our y-intercept, but in this case, obviously we do have a fraction. My y-intercept is C over B. C is 5, B is 4, so it's 5 over 4. Now, if we wanted to know what this was as not a fraction, because it's kind of tough to look at your graph and say, well, where is my first point going to be if my intercept is 5 over 4? I don't know where to put that. What you could do is take a calculator, which you all should have some at your tables, but did we assign our orange calculators? Okay, so if you guys want to use those, you're always welcome to use them every single time. They're over there. And if you forget what number is yours, if you open the computer cart, there's a little paper inside that should have your names and what number next to you. But I'm just going to type in 5 divided by 4. 5 divided by 4 equals 1.25. So that would mean when I graph my y-intercept, I'm going to go up to 1, a little bit above 1.25. And on this one, I wouldn't expect you to do it perfectly since it's not a whole number. You would just kind of guess about where 0.25 would put you. Just know it would be slightly above 1. But we're not going to worry about graphing these too much today. I just want us to get some good practice identifying the slope, identifying the y-intercept. Okay, so here's our first example. Before we do another one, do we have any questions about how we got any of these numbers?
That negative A, so you got AX plus BY equals C.
Yes.
That A is always going to be a negative?
Always, unless you start with a negative. Like if I had, let's do that for our second example. Let's try that. So number 2, I'm actually glad you pointed that out because I didn't even think of that. Let's try to identify our slope and y-intercept for this equation. I have negative 2x plus 3y equals find my slope and my y-intercept. So
The
Our-
slope would be, negative 2/3.
let's see. What's our a first of all?
-2.
It's negative 2. You're right, it is going to be 2/3. Or yes, it is going to be 2/3, but since we're starting with a already negative,
It'll be
Flip
positive.
it to a positive.
yes, the negative version of a negative is a positive. Negative just means opposite. So we're just changing it, but you got the numbers right. That's perfect. So our a is negative 2. Our b is 3. And our c is 9. So our slope, tell me again, what's our slope?
2/3.
Good. It will be 2/3 because we started with an a that was already negative. So the negative a is going to be positive. We get 2/3 because it's negative a over b. Now, what would our y-intercept be?
9.
9/3.
9/3.
Which will make it 3.
Yes, because we have 9/3. 9 divided by 3 is 3. So our y-intercept is 3.
So, okay, so it's gonna be A over B and then C over B?
Negative a over b and then c over b.
Okay.
Yes.
Alright.
I would just keep this in your notes, highlight it, circle it, put a sticky note on that page if you need to. Because you can use your notes on quizzes and everything. So you will always be able to reference this. I would, it's something that you'll need to have handy. So in case anybody didn't know, I do have sticky notes for all of you at your tables. They should be in those rectangle bins. If there's any pages that you ever want to bookmark, like, let me show you. You can take a sticky note, and I actually love to label certain pages. So I might say, Ax plus by equals C, slope and y-intercept. And I might stick it in my notebook like this so that when my notebook is closed, I can see where this is in my notes always. So if you guys want to use those sticky notes, those are there for you guys to use. Absolutely. Yes.
So when you using that -2 for A, you just want to make sure that your A still be positive.
Yes. So because our slope is negative a over b, that means if our a is positive, our slope is negative. If our a is negative, our slope turns positive. It does the opposite every time. So let's do a few more examples together. We're going to get really comfortable with this. I'm going to let you guys do lots of practice on it. So let's look at another one. Number 3 is what we'll call it. I'm going to give you negative 5x plus 10y equals 20. So what's the first thing I should identify?
A, B, and C.
A, B, and C. Good. What's my A?
5.
Not 5. -5. 5 is right, but it's got to be -5. That's our A. And sometimes it helps putting parentheses around it because that is going to affect our answer. We've got -5. What's our B?
10y.
10. And what's our C?
20.
20. Good. Good, good, good. So let's first find our slope. What is my slope using letters without numbers plugged in yet?
A and B.
A and B. Now, not just plain A and plain B. What's special about the A?
Negative.
Negative A. It's got to be negative A, which means whatever A is, if it's positive, you make it negative. If it's negative, you make it positive. We're changing it. So A over B, negative A over B. So what would our slope be using numbers?
5 over 10.
Good. Positive 5 over 10. Can we simplify 5 over 10?
Yeah.
Yes. What can I simplify that to?
1/2.
1/2. Does anybody need a refresher on how we simplify fractions? Sure. Yeah, let's do that. So I am going to a little sticky here. So we started with 5 over 10. Basically, whenever I have a fraction and I want to simplify it, I want to ask myself, can I divide both of these numbers by the same thing? So I always like to start with 2. Can I do 5 divided by 2 and 10 divided by 2?
No.
No, I can't. What about 3?
No.
No. What about 4?
No.
What about 5?
Yeah.
Yeah, so let's do 5 divided by 5 and 10 divided by 5. What's 5 divided by 5? 1. What's 10 divided by 5? 2. And that's how we get 1/2.
So you'll always want
You do want to simplify, yes. Always try and simplify. So our slope is 1/2. And that's simplifying it is also going to really help us whenever we get to graphing, because going up 1 and over 2, you're a lot less likely to make a mistake than if you tried going up 5 and over 10. Now, if you go up 5 and over 10, you are still getting the right answer. That will still give you the same line. There's just a little more room for mistakes with bigger numbers. So I always say, simplify when you can. If you get 5 over 10 on an assignment where I don't tell you specifically that you need to simplify, I'm not going to take points off for it because it is the right answer. But if I tell you need to simplify, then we need to simplify. Okay. Any questions about what we just did here? Okay, let's look at our y-intercept then. So our y-intercept, what letters are we using to find that?
C and B.
Good, C over B. So what number should I plug in?
20 over 10.
Good, 20 is C, 10 is B. So 20 over 10.
2.
Yes, I can simplify that to get 2. Is anybody confused about how I got 2 from 20 over 10? I'm going to explain it anyway, just in case. So it's the same process, 20 over 10. If I were to count up, first of all, I guess I could, this would be a slower way to do it. Like, oh, can I divide them both by 2? Yes, I can. I'm going to get 10 over 5. And then you'll notice that 10 and 5, it's the same numbers as above. I divide them both by 5, and I get 2 over 1. And remember, any number over 1, it's just that number, it's 2. You could also just type it in your calculator, 20 divided by 10. Like this. 20 divided by 10, and you get 2. Fairly simple. Any questions on this example here? Okay, well, we are getting about to that time. It's 10:21. I think we deserve a little break. We've been going at it for a minute. Let's say try and come back about 10:40, okay? And I'm gonna try not to be late this time. So come back at 10:40. We'll do some more practice with these. And yeah, feel free to stay in here if you want. Feel free to leave if you want. I am gonna go out and do some things while I take a break. But I'll see y'all in a bit. So we are back from our break. And I'm gonna turn the page to page 3 of our notes.
Still doing the example.
Say it again.
We still doing the example.
Still doing the, I don't know why I can't hear you.
The example.
The examples, yes. We're still doing a few examples together, and then I'm going to give you a bunch to try on your own. And I'll be around to help one by one individually.
Okay.
It's still day 12.
Her mouse is
Not yet. Some more examples. Give us a few more of these, and we're still doing standard form, the ax plus by equals c. I'm going to pull page 2 out of here so I can look at it. I don't want to have to rewrite that again. I'm just going to put it below. So we've looked at a few examples where our a is negative, but let's look at a few where we have b and c that might be negative as well. So here is the 4th example. What if we had negative 2 y Okay, so in this equation, you're going to notice that we don't have any plus. These are all negative numbers. We've got negative 2x minus 5y equals negative 15. So the first thing we want to do always is identify our a, our b, and our c. So I'm just going to write them out to the side. A, B, C. Okay. What number do we have for a?
-2.
Good. We've got negative 2 for a. What about b?
5y. -5.
Ah, yes. Since we have minus 5y, that means our b is going to be negative. We have negative 5 for b. You'll notice in the other examples, we would have a positive b if it was plus something y. But since we have minus 5y, our b is negative 5.
C is negative 15.
Good. And C is negative 15. Okay. Got my little guide below here. I know my slope is negative A over B. My y-intercept is positive C over positive B. So let's see. Slope. What would my slope be?
5.
We've got negative 2 that does turn into positive 2 over B. What's our B? Negative 5. So it's going to be 2 over negative 5.
So the only one that we would change is gonna be the A.
Yes, A is the only one that we change. B, if it's negative, it stays negative. If it's positive, it stays positive. C, if it's positive, it stays positive. If it's negative, it stays negative. A is the only one that's different. And the reason for that is because if you notice, whenever we rearranged the equation, A is the only one that gets subtracted to the other side of the equation. So that's why it ends up being negative A. You see that? That's where that came from. B, we just divide. That's why B stays the same. C doesn't move. That's why C stays the same. So B and C, you don't change them. But A is negative A. So if it's negative, we turn it positive. If it's positive, we turn it negative. Just A though. The rest do stay the same. So our slope is 2 over negative 5. You could also think of it as negative 2 over positive 5. Either way, we just know that we have a negative slope here because one of our numbers is negative. Okay. So what is our y-intercept now?
Negative 15.
Yeah, so we have,
I mean, subtract from that.
yeah, no, that's good. It was C over B, which is negative 15 over 5, which simplifies to what? 3, positive 3. Now, that's another thing that's good to keep in mind. If I have a negative divided by a negative, it becomes a positive. Those negatives cancel. Becomes positive 3. And remember, we can also check that on our calculator. I can type in negative 15 divided by negative 5, and I'm going to get positive 3. And graphing 3 is going to be a lot easier than trying to figure out where the heck my point is going to go for negative 15 over negative 5. That, I don't even know that we could do that. So our y-intercept is 3. Our slope is negative 2/5. Okay, any questions about that one?
We do another one.
Absolutely. Let's do some more. Number 5, let's try. About 2x. I'm going to give you a very similar one to the one before. This time I have positive 2x instead of negative 2x. So 2x minus 5y equals negative 15. Super similar to the last one, but it is different. So let's start with figuring out what is our A, what is our B, what is our C.
2x is the A.
Yes, so not the X, but 2. Yes.
Sorry.
2 is our A. What's our B?
Negative 5.
Perfect. Negative 5. What's our C?
Negative 15.
Negative 15. Good. I'll just put these in parentheses so you can see where those numbers came from. Okay. So now that we have our numbers identified, this is what we're using to help us find our slope and our y-intercept.
2 over negative 5.
Let's see. So our slope,
Negative 2 over negative 5.
Ooh, yes, because remember, so on the last example, we did have positive 2 over negative 5 because we started with a negative 2. And remember, slope is negative a over b, so opposite a over whatever b is. That's how we got positive 2 over negative 5. This time we start with a positive a. So we're going to have a negative 2 over b, which is negative 5. Now, what happens to that slope since we have a negative divided by a negative? It turns positive. Our slope is positive 2 over 5. Good. Positive 2 over 5. Now let's look at our y-intercept. What letters do we need for the y-intercept?
15.
Yeah, c over b. So negative 15 over negative 5, exact same as the last one. What does that simplify to? 3, positive 3. Good. Good, good, good. I think the trickiest part about these is remembering that the A we change and the others we don't. Negative numbers, no matter what class I teach, it always gets everybody all messed up. Negative numbers are tricky. They are. And the best advice I can give you when working with negatives is to just work slowly, be careful, double, triple check everything. Make sure that you're writing the correct sign. If it's positive, the A turns negative. If it starts negative, it turns positive. The A is the only one that changes. Do we have any questions on 4 or 5?
So you have the 2 negative on your slope, you have to turn them back to positive.
Yes, yes. Anytime you have a negative divided by a negative, it becomes positive. Those negatives cancel. And we can see that also on our calculator. If I were to do negative 2 divided by negative 5, now it's going to give me a decimal, but it will be a positive decimal, positive 0.4.
Gotcha.
Now on the other one, 2 divided by negative 5, we have a positive divided by a negative. We're going to get a negative answer, negative 0.4. When the signs are different, it's negative. When the signs are the same, it's positive. Okay. Good questions. Do you guys want to do another one before I have you try some more on your own?
Yes.
Okay. Let's see. About 3x plus 4y equals negative 8. To side A, B, and C. That's a great first step to start with. So in this equation, 3x plus 4y equals negative 8. What would my value for A be?
3.
3. Perfect. A is 3. About B? 4. And what about C? Negative 8. Good. Good, good, good. So keeping this in mind, I'm going to kind of scooch this up so we can see our helper guide. What is my slope going to be? Negative 3 over 4. Good. A is 3. Slope, we use negative A. So negative 3 over 4. How about our y-intercept? C is, yep, -8 over B is 4. So we have -8 over 4. And what does that simplify to? 8 divided by 4, or sorry, -8 divided by 4 is -2. Good. And we know it's negative because I'm doing a negative divided by a positive. The signs are different, so we get a negative answer. Awesome. Awesome, awesome. Do you have questions about this 6th example here? Okay. Is it starting to click a little more? Yeah, I think sometimes the only way to make something make sense is to just do it a bunch. That's all you can really do. We just drill it until it's like, okay, I see what I'm doing now. So here's what I'm going to do. I am going to write out just a ton of these, a bunch of them. And I'm going to set a little timer here in a minute and have you guys practice identifying the ABC, the slope, the y-intercept. Okay? I'm going to come around and help you guys. If anybody needs it, just holler at me. And then we'll go over them together. So does anybody still need this, or can I turn the page? Okay, I'm going to turn the page. So this is going to be page 4. Okay, bunch of them. So I think while I'm writing them, I'm going to pause this so the video isn't just me writing and wasting time. So I'll pause it while I'm writing. Oops. So for anyone watching at home, here's all the problems written out. We just had about 25 minutes or so, and everyone just worked on these on their own. Now we're going to go over the answers. So we are finding slope and y-intercept for standard form equations. Ax plus by equals c. So let's look at number 1. Number 1, what is our A, B, and C, first of all?
2x is A.
My A is 2, my B is 3, my C is 6. So what's my slope?
2 over 3.
2 over 3.
Negative
2 over 3. Good. Remember that A becomes negative for our slope. We've got -2 over 3. And what's our y-intercept?
2.
2? How'd you get 2?
That's 6 over 3.
Yep, we had 6 over 3, which simplifies to 2. 6 divided by 3 is 2. Okay, any questions on number 1? Awesome. Okay, let's look at number 2. What is our A, B, and C?
A is -5.
Good. A is -5, B is 2, C is 10. Okay, so using -A over B for our slope, what's our slope?
5 over 2.
5 over 2. Good. That is positive 5 over 2. Remember, we flipped the sign for our A and our slope. And what would our y-intercept be? 10 over 2, which simplifies to 5. Good. Perfect. Okay, questions on number 2. Right, let's look at number 3. What's our A, B, and C?
-3, -3,
Mhm.
9.
Good. We have -3 for A, -3 for B, and -9 for C. We got 3 negatives here. So using -A over B,
1, 1,
our slope is going to be, what is it?
1, 1, 1 over 1.
1 over 1. So let's see. We've got -3
Over -3.
and -3, but wait.
So you have a +3 over -3.
Yeah. So remember, if we start with a -A, when we do slope, it becomes +A. So we're starting with 3 over -3, which does simplify to 1 over 1, but it's not +1 over 1. It's negative, okay?
But can you just put it as a whole, as like?
You could also say -1. Both are correct, absolutely.
Why did the bottom one be negative?
So whenever we are writing our slope, it actually doesn't matter whether you write it on the top or the bottom, because -1 divided by +1 is still -1. +1 divided by -1 is still -1. So if you wrote it on the bottom one, that's correct. If you write it on the top one, that's correct. Either way is totally fine. Okay, any questions about the slope before we do y-intercept? Okay, what's our y-intercept? -9 over -3.
Simplify to 3.
Yes, that simplifies to +3. Good. Does anybody want clarification on how that became +3?
3 divided by 3, and 3 and a 9.
Yeah, if I take -9 divided by -3, I'm going to get +3. Remember, negative divided by a negative gives us a positive. They cancel out. Okay, so number 3, our slope was -1. Our y-intercept was +3. Any questions on number 3? Okay, let's try number 4. What's our A, B, and C?
2.
2 is A.
-4.
Good. -4 is B.
-8 is C.
-8 is C. So our slope, what is that going to be?
-2 over -4.
Good. -2 over -4. What does that simplify to?
1/2.
Positive or negative? Positive 1 over 2, 1/2.
And we gotta put 0.5.
You don't have to write it. I would always suggest not using a decimal for slope, just because whenever I have 0.5 as my
Yeah, you're
slope,
right.
I'm like, well, what's my rise and my run? A fraction is always going to be easier to work with.
Okay.
You could do 0.5, but then you'll have to turn it into a fraction when you graph it.
So it's only the y-intercept.
Mm-hmm. Yes. Now for y-intercept, what do we get?
-8 over -4.
Perfect. -8 over -4, which,
+2.
yes, that simplifies to +2. The 2 negatives cancel. That's why how we get 2 positive numbers here. Okay, questions on number 4? I'm gonna zoom in a little on these because I know I've got it kind of squished together. I'm writing pretty tiny. Okay, let's look at number 5. What's our A, B, and C?
6, 3, and 12. 6x, 3y, and -12.
Yes, and whenever we're identifying our A, B, and C, we just want to include the numbers. We don't want to worry about the X and the Y, because if I put an X in there, it's gonna mess us up later on. It's just the letter that, or sorry, not the letter, the number that's next to X and the number that's next to Y.
Right.
So A is 6, B is +3, and C -12. So slope Negative a over b, what's that gonna give us?
-6
Mm-hmm.
over 3.
-6 over +3, what does that simplify to?
-2 over 1.
-2 over 1. Or -2. Both are correct. Now, if you kept it at -6 over +3, that's also correct. It's just not simplified. So you'll still have the right graph later on. That's perfectly fine. Your points will just be further away from each other. It'll be correct. It'll just be a little bit more spread out. Okay, so how about the y-intercept?
-12 over 3 simplifies to -4.
The -12 for C over +3, that's B. And that simplifies to, you said -4?
Yeah.
Perfect. -4, because 12 divided by 3 is 4. We have a negative divided by a positive. That gives us a negative answer. Okay, any questions on number 5? All right, let's do number 6. A, B, and C. What's that?
-4.
Mm-hmm.
2.
Mm-hmm.
-8.
-8, good. There's our ABC. What's our slope?
4 over 2 equals 2 over 1.
Good. Remember, it's -a over b. So since a is -4, negative a is +4. So 4 over 2, and that simplifies to 2 over 1. And again, if you kept it at 4 over 2, that's still right. You're not going to get counted wrong for that. Your graph just will be more spread out. So we have our slope. How about y-intercept?
-8 over 2
Good. C over B, -8 over 2,
equals -4.
-4. Awesome. Any questions on number 6? All right, let's try 7. What's our ABC?
-3.
Mm-hmm.
6. 12.
Good. -3, 6, and 12. What is our slope?
3 over 6.
Yes, +3 over +6, which simplifies to 1/2. Good. And our y-intercept?
12 over 6.
12 over 6, that's C over B,
2.
which simplifies to 2. Very good. Awesome, guys. Okay. Now that we're halfway through these, does anybody feel like they notice a mistake that they're consistently making? Is there any part of this that seems really tricky?
Changing the minuses to the pluses has got me.
Okay, yes, changing the minuses to the pluses, that negative a is tricky. Maybe simplifying the fractions is a little tricky. That can be tricky.
I just have to remember to put my my 1 underneath the slope when I get my answer.
Right. So if you do get a positive number for your slope, like in number 5, we got -2 over 1. If you wrote -2 without the over 1, that's fine. I would count that right. That is perfectly correct.
Oh.
The only reason that I always encourage to remember that it's over 1 is for whenever we're using rise over run and we're graphing the line. Because sometimes if we just see -2, we might think, okay, I'm going to go down 2, and that's where my next point is. It's just to help us to remember that we do still go over 1. So -2 or whatever your answer is, the +2 on number 6, that is correct. That's perfect. So you don't have to write it over 1, but it helps us graph. Okay, any questions on 1 through 7? Can we go on to 8? Here is number 8. 10x plus 20y equals 40. What's ABC?
10, 20, 40.
Good. A is 10, B is 20, C is 40. Find our slope.
Negative 10 of 20.
Yes, A over B, negative A over B. So negative 10 over 20.
Simplified negative 1 over 2.
Good. Negative 1 over 2. Perfect. And a trick for simplifying fractions where if the numbers both end in 0, you can just cross the zeros out. 1 over 2. Neat little trick. That'll work with any number. Like quick example to the side. If I had like 3, let's see, that's 30,000 over, you don't have to write this, over 120,000. I can cross off pairs of zeros and simplify it like that. No, dun. 3 over 12. And you could simplify that more, but this would at least get rid of part of it. So zeros cancel when they're on top of each other. Kind of cool. All right, so there's our slope. What's our y-intercept?
40 over 20.
Perfect. 40 over 20.
Wait, 6.
Equals
18.
2.
Huh?
Equals 2.
Oh, were you asking
No,
a
she's
question?
telling me something.
Oh, okay, sorry. Okay, equals, what'd you say? 2. Perfect. And you can see this would also work. It would simplify to 4 over 2, which 4 divided by 2 is 2. Awesome. Any questions on number 8? Okay, so due to time, we only have about 10 minutes left, and I said I was going to try to get you guys out early.
Can we do 14?
Do which one?
14.
Yes, 14. Absolutely. This one's tricky. What's our A? What's our B? What's our C?
X, Y, negative Y.
Okay, so we have an X, we have a negative Y. What does that mean our numbers are?
1.
1.
1
Negative 1.
and negative 1. So A is what?
1.
1. B is what?
Negative 1.
Negative 1. And C is
3.
3. So anytime there's not a number in front of a variable, just remember it is an invisible number 1. So same process. A is 1. B is negative 1. C is 3. So what would our slope be?
1 over negative 1.
So let's see. Our slope is negative A over B. If A is positive 1, what's negative A?
It's negative 1 over negative 1.
Negative 1. Yeah, we got to be careful. Negative 1 over negative 1. And what does that turn into? Positive 1. Those negatives will cancel. So we'll get 1 over 1. Or you could say just 1. Both of these are correct. Okay, any questions about how we got that slope? The reason we knew that A and B were 1 and negative 1 is because there was no number next to X. There was no number next to Y. And remember, if there's not a number to tell you how many there are, we can just say, okay, well, how many X's are there here? 1. How many Y's are there here? Well, it's negative Y, so negative 1. Okay. What's our y-intercept for this one?
3 over negative 1.
Yeah. Oh, we've got C over B, 3 over negative 1. 3 divided by negative 1 gives us negative 3. There you go. Okay. All right. I am going to, for the sake of time, like I said, I want to give you time for your exit ticket today. I'll give you answers to the rest of these here in just a minute, but first I'm going to give you an exit ticket, and I'm going to put this to the side. Now, remember, exit tickets are always just due by Friday at noon. So you still have lots of time to finish this. But for your exit ticket, I want you to And if you want to wait, I will make copies of these as well if you don't feel like writing it down. But if you don't want to wait, you're welcome to. I want you to identify slope and y-intercept of each linear equation. And just a time management tip, this class, I try to make it so that you don't have to do things at home. And I know we only have about 5 minutes left. If you're worried about getting this done by Friday, you can do it during the do now time tomorrow. Okay, I give you like 15 minutes usually at the beginning of class. So don't freak out about making sure you finish it tonight, because I'm not giving you a lot of time today, and that's on me. So number one, I'll give you a tricky one. Negative x plus y. I'll give you a spot to write your A, your B, and your C, and then your slope, and your y-intercept. Two. C. Slope. Intercept. And I am just going to make you do 2 today. So I will go ahead and end this video, and I'm going to freeze the screen for you guys. I will make copies of this to put in people's folders who are not here. If you want a copy, just raise your hand when I get back. But you guys are free to go, whether you do it before you leave or whether you decide to wait and do it tomorrow. So that is all.